Well, just like linear equations, linear inequalities have systems as well, and it's along the same concept. So, a system of inequalities is two or more linear inequalities. The solution to a system of inequalities is the overlapping region. So remember what we did yesterday, okay? When we do this and we shade, we're shading all the possible solutions. So when we have a system, it's the two areas that overlap, meaning any point within those two areas work for both inequalities. So let's go see what that looked like. Remember, it's a system, so it's two or more. Before I can graph, it has to be in slope-intercept form. So let's just start with my first inequality. I'm going to solve for y. So y is greater than negative x minus 1. My slope is negative 1 over 1, and my y-intercept is negative 1. So I put a point at my y-intercept. I'm going to go down 1 and right 1. But I can also go up 1 and left 1. It doesn't matter, okay, as long as I have one negative direction. I'm going to put a dashed line. Why do I have a dashed line? That's because my inequality symbol is just greater than. So now I pick a point, and I'm going to pick 0, 0. 0, 0 is to the right of my line. I plug it in to my inequality. 0 is greater than negative 1, so I'm going to shade where that point is. Since it was a solution, I shade it, okay? Now, all I have here is my first inequality. I need to go graph my second. Again, I got to solve for y, so I subtract x from both sides. I'm dividing everything by negative 1. But look what I did. I switched my inequality symbol because I divided by a negative. So I'm going to identify my slope and identify my y-intercept. I'm going to place a point at negative 5. I'm going to rise 1, run 1. Rise 1, run 1. I'm going to draw a dash line because it was a less than symbol. So when we did systems of equations last week, technically I would have already had my answer. However, these are inequalities, meaning I actually have to shade, okay? So I'm going to pick a point that's on one side or the other of my blue line. So I'm going to pick 0, 0 again because it works. When I substitute it in, 0 minus 0 is 0. Is 0 less than 5? The answer is yes. So I'm going to shade everything to this side, okay? The solution to this system is the point where that blue and that pink overlap. So if you notice, when you do two different colors, there's actually almost like a light purple shade, okay? That's this area here. This is your solution, meaning any point there would make your inequalities true. This is why Mrs. Nell and I have said you need two colors. Because what I do is I graph one entire inequality, shading and everything. Then I shift colors and graph the next one. This will definitely help you understand which one you're working with. Let's go try another one. So I'm going to take my inequality. I'm going to solve for y by adding x to both sides. Then I'm going to divide everything by 3 so that I have y is greater than 1/3 x plus 7. So my slope is 1/3 and my y-intercept is 7. I'm going to place a point. I can go up 1, right 3, or I can go down 1, left 3. I'm going to draw my line, and again it is dashed because it is a greater than symbol. I'm going to pick a point. Guys, if you can pick 0, 0, meaning the line doesn't go through it, pick 0, 0. It's going to make your life easier. So when I plug that in, I end up with 0 being greater than 7. Is that true? No, it's not. So then I do not want to include that point, meaning that point did not work. So I shade on the other side. Okay, I'm not done. So I now need to graph my next linear inequality. Okay, so my slope is -1/1, and my y-intercept is b. We luck out, my inequality was already in slope-intercept form. So I place my y-intercept. I'm going to go down 1 and right 1. I'm going to also go up 1 and left 1. The thing about inequalities, you don't have to keep going till your lines touch. I can just draw my solid line. Now the line is solid because my symbol is an or equal to. But I still have to pick a test point. I'm going to pick 0, 0. When I plug in 0, 0, I end up getting 0 is greater than or equal to 4. That is not true. So I do not want to shade my point. So I'm going to shade where the point is not. Therefore, the point where, or not the point, I should say the overlapping region, okay? Your overlapping region is your solution, anything in there. Okay, so here we are. Look at this one. Remember what we did last night? I have x is less than -4. Remember, it's a vertical line at x equals -4. It should be dashed because my symbol does not have the or equal to. I still pick a test point, okay? You can pick any x value and plug it into x. But what the inequality is really saying, it's saying all the values of x are less than -4. So if you look, everything on this side is less than -4. Okay? Well, I've graphed one inequality. I need to go graph my next one. But I need to solve for y. Okay, then I'm going to divide everything here by 2. It's a +2, so my inequality symbol is going to stay put. So my slope and my y-intercept, okay, would be -1. I'm going to go down 3, right 2, or up 3, left 2. I'm going to connect and have a solid line because my symbol was less than or equal to. So now I need to pick a point. I'm going to pick 0, 0. Whenever you have a fraction slope, you want to try and pick an x of 0 as best as you can. The y doesn't matter, but if your slope is a fraction, you want one of your coordinates to be 0 for x. So when I plug that in, I get 0 being less than or equal to -1. That's not true. So I don't want to include that green point. I'm going to shade to the other side. Notice where your blue and your pink overlap. Those are all your possible solutions to this system. I can pick any point in that region. I could pick, let's see, 1, 2, 3, 4, 5. I could pick -5, 0. If I plug that in, it would work. So now that you've seen this, we want you to try number 3 on your own. Anything else on the worksheet, you are more than welcome to try, but we're going to be looking at number 3. Okay, remember, you can't graph anything until it's y equals mx plus b. If it has an or equal to, it's a solid line. And we're looking for the place where our graphs, where we've colored them, overlap.